Hello everyone, I am Siddharthan. This is the ninth project video in our machine learning project series, and in this video we are going to build a machine learning system that can predict gold prices based on several other stock prices. Okay, so first of all, let's try to understand the workflow which we are going to follow, and then let's get into the hands-on part where we will be building this machine learning system using Python. Okay, so this is the workflow which we will follow. So first we need the gold price data. Okay, so we have a data consisting of gold prices for several days in a period of 10 years. Okay, so we will be using this data to train our machine learning algorithm. Okay, so when we train this algorithm, so when we give new value, it can predict the gold prices for that specific value. Okay, so this is what we are going to do. And once we have the gold price data, we need to do some data pre-processing. So we cannot feed this raw data to our machine learning algorithm, so we need to process this data properly. And once we process the data, the next step is to analyze the data to find which features are important and which features are correlated with each other, and some data visualization techniques. So that will we will be seeing in data analysis part. Okay, so after that, so it is train test split. So we will split our original data set into training data and test data. Okay, so we will use this training data to train our machine learning model, and we need to evaluate our model. So we need to find how well our model is performing. So for that, we will be using a test data to test our machine learning model. Okay, so in this case, we are going to use a random forest regressor model. Okay, so this is a regression problem, so we are going to use a regressor model. So we will be using a random forest regressor, and I'll just give you a brief explanation about how random forest regressor works when we implement this algorithm in this video. So we'll be discussing it later in this video. So once we feed this training data to our random forest regressor, it can make new predictions. So once this model is trained, we will evaluate our model based on the test data which we have splitted. Okay, so this is the workflow which we will follow. Okay, so now let's get into the hands-on part. So before starting with the hands-on part, I'll just give you a quick introduction about my YouTube channel. So in my YouTube channel, I'm making a hands-on machine learning course with Python. So if you go for my channel for the first time, you will see this machine learning course curriculum video. So in this, I have explained about all the modules and the videos which we will be seeing in the near future. And you can also download the course curriculum from here in the description of this video. Okay, so you can also go to this playlist. So in our machine learning course, we have completed three modules as of now. So the first module is on machine learning basics, the second module is on Python basics for machine learning, and the third module is on important Python libraries. So in this module, I have explained about NumPy, Pandas, Matplotlib, and Seaborn libraries. Okay, so we also have a fourth module which is on data collection and pre-processing, where we discuss about several data pre-processing techniques. So we also have machine learning project videos, and I will be posting project videos every Friday. Okay, so I will be posting 3 videos per week. So the 2 videos will be on Monday evening and Wednesday evening, which follows this machine learning course. And on Friday, I will be posting one machine learning project video. Okay, so and now we are going to do this programming in Google Collaboratory. So this environment is called as Google Collaboratory, and in Google Collaboratory we can run Python programs. So if you are new to this Google Collaboratory, go to my second module, which is Python basics for machine learning. So there you can see this 2.1 index video. So it's on Google Collaboratory for Python, and in this video I have explained about how to use Google Collaboratory and what are the various features of Google Collaboratory. Okay, so you can also find the link for my Telegram channel, my Facebook group, and LinkedIn ID. So do join the Telegram group, so I'll just notify you once I post new videos. Okay, so with that being said, let's get our hands on this project. So you need to connect your Google Collaboratory from here. So once it's connected, it will show this tick mark. So the first step is to import the libraries. Okay, so we're importing the libraries. So we call this libraries or dependencies. So we need some functions and libraries. So that's what we are going to do here. So let's import NumPy as NP. Okay, so the general convention of importing NumPy is NP as a short form. And now let's import pandas. So I'm importing pandas as PD. So NumPy is used to make some NumPy arrays, and pandas is useful for making some data frame. So data frame are nothing but a structured table. So our data will be in a CSV file. So CSV represents comma separated value, and it's not very easy to analyze the data from a CSV file. So hence we use this pandas data frame. Okay, so next we will import matplotlib. Import matplotlib dot pyplot as plt. So matplotlib is useful for making plots and graphs, and we will use another library as well for this plotting. So it is called as cbon. So import cbon as sns. Okay, so it is also useful for making some plots. And now from sklearn dot model selection, I'm going to import train test split. So as we have seen earlier, we need to split the original data into training data and test data, and for this we will use this train test split function. Okay, so next we will import our random forest regressor model. So from sklearn dot ensemble, we're going to import random forest regressor. Okay, and now let's import from sklearn input metrics. So this metrics is useful for finding the performance of our model. So it's basically to evaluate our model to find the error score and accuracy score and such kind of things. Okay, so you need to press shift plus enter to run this particular cell and go to the next one. Okay, so I have already uploaded the dataset file. So this is the gold price dataset file. So it is a CSV file. I'll give the link for this dataset file in the description of this video. So this dataset is also available in Kaggle. So the next step is data collection and processing. So I'll make a text here as data collection and processing. Okay, so first we need to load our data set. So loading, I'll just make a comment as loading the CSV data to a pandas data frame. Okay, just one second. Okay, so pandas data frame. So let's create a variable as gold data, and we will store this data frame in this variable called as gold data. And gold data is equal to pd.readCSV. As we have a CSV file, this read CSV function will help us to read the CSV file and store it in a pandas data frame. And you need to mention the code here, and inside the this codes we need to paste the path of this CSV file. So you can go to this options here and copy the path. So for uploading the dataset to this collaboratory environment, so you need to go to this files, and there you can click this upload to session storage options, or you can just right click here and upload. So when you give this upload, there will be a prompt, and from that you can upload your dataset file to this Google Collaboratory. Okay, so read CSV, and now I'll paste the path which I have copied. So now let's run this. So press shift plus enter. Okay, now we have successfully imported the CSV file to a pandas data frame. So first, now let's understand what are the data available in this data set. So what I'm going to do is print first 5 rows in the data frame. Okay, so for that we need to use the function called the SID. Okay, so we need to use this data frame name, which is gold data. So gold data dot read. Okay, so when I run this, it will print the first 5 rows of the data frame. So you can see here we have the first 5 rows, and we have the data from the date 1 to, so the first the number represents the month, the second value represents the day, and the third represents the year. So we have the date here, and so we have the date from 2008, the year 2008, and we have this SPX. So SPX is also called as S&P index. So it is the capitalization index of 500 companies which are publicly traded. So it is one of the stocks that is available. Okay, so this is the SPX stock value, and this is the GLD. GLD represents gold price. So this is what we are going to predict. Okay, so these are the gold prices for these dates, and we also have this USO. So USO represents United States oil price for these dates, and we have the silver price value, and also we have the United States sorry the currency pair of European currency and United States dollar. So this is called as a currency pair. And so if 1.47 represents one European, or 1 euro is equal to 1.47 USD. So this is called as the currency pair. So what we are going to do is we will be training our machine learning model with these stock prices. So with this currency pair with silver value and this SPX and USO. So by analyzing these values, we will try to predict the gold value. Okay, so that's what we are going to do here, and we won't do forecasting. Okay, so forecasting is a separate problem. So you can also try forecasting. For forecasting, you can use some models like LSTM. So LSTM is also known as long short term memory. So we will be seeing that project as well, in the future in our YouTube channel. So in which we try to forecast the gold prices, but in this case we are going to predict the prices based on these stock prices. Okay, so these are so totally we have this six columns, and in the six columns we will be predicting this gold prices. Okay, so we have the date from 2008, and let's see until which date we have the values. Okay, so here we have printed the first five rows, and now we are going to print the last five rows of the data frame. Okay, so again mention the data frame name, which is gold data dot tail. So this add function help us to print the first five rows, whereas the tail function will print the last five rows. Okay, so you can see here we have totally 2289 values, and the date is 16 5, so 16th May 2018. Okay, so we have data of about 10 years, and it's quite a large data. Okay, so it's very good to use a large data set. Okay, so now let's understand more about this data. So let's see how many data points we have in total. So number of rows and columns. So you can find the number of rows and columns in a data frame using the function shape. So mention the data frame, which is gold data dot shape. I'll run this. So now you can see here, so totally we have 2290 rows and 6 columns. Okay, so this is a good number of data, and we will use this data for our predictions. So let's also get some more information about the data types of this data. So getting some basic information about the data. Okay, so gold data dot info. So this info function will give us some information. So let's see what are those. So you can see the number of entries, the number of rows and columns here. So totally we have 6 columns, and all the columns are here. So we have totally 2290 non-null values. That means we don't have any missing values. So the data type is given as object for date, and the other data types are in float 64. So 64-bit float. So they are numerical values. So we don't need to do any processing much there. Okay. So you can also check the number of missing values. So checking the number of missing values. So let's see how we can do that. So mention the data frame here. So gold data dot is null dot sum. So this function will give us the number of missing values in each column. So it says 0. That means we don't have any missing values. So if we have any missing values, we can use a method called as imputation. So I have already posted a video on handling the missing values, or I'm not sure, like it will be posted very soon. Okay, so in the case of imputation, we will use a mean or median value for handling the missing values. Okay, so that video will be posted on coming Monday. Okay, so we don't have any missing values in this case, which is a good thing. Now let's get some statistical measures of this data. Getting the statistical measures of the data. Okay, so mention the data frame, which is gold data dot describe. So this describe function will give us some statistical measures like mean, standard deviation, etc. Okay, so data frame also describe. Okay, so I just made a spelling mistake here. So I'll run this now. Okay, so we have this count. So count means is the number of data points we have. So totally we have 2298 data points, and this is the mean value for all the columns. So for SPX column, this is the mean value 1654, and for gold column the mean value is 122, and this is for US1 other things. Okay, so we also have the standard deviation value and the minimum value for each cases, and we have the percentile values and the maximum value. So percentile value, so these are not percentages but percentile. So 25 percentile means 25 percentage of values are less than this 1239, and 50 percentage of the values are less than the value 1551. So those kind of things. So these are some statistical measures. It tells us what is the mean, like what is the range the value lies. So now let's do some analysis on this data. So what we are going to do is find the correlation between the various columns in a data set. So correlation. So there are basically two types of correlation. The first type of correlation is positive correlation, and the second type of correlation is negative correlation. Okay, so while we are working on some regression project, we will always check this correlation. So it tells us which columns are related to which column. Okay, so in the case of positive correlation, so when we take two variables, one variable will increase if the other variable decreases. So such kinds are known as positive correlation. So we can also say that these variables are directly proportional. In negative correlation, if one value increases, the other value decreases, so they are inversely proportional. Say for example, if the gold price increases, if the silver price also increases, so in that case the gold column and the silver column, they are positively correlated. Say if gold price decreases and USO price increases, so then they are negatively correlated. Okay, so now let's see how we can find this positive correlation and negative correlation value. Okay, so I'll create a variable called as correlation, and correlation is equal to gold data dot core. So CORR. Okay, so this will give us the correlation between the various features. So let's run this. Okay, so now we can construct a heat map to understand this correlation values. Constructing a heat map to understand the correlation. Okay, plt dot figure, and let's mention the size of the figure we want. Figure size is equal to 8,8. So you can just mention any size you want. So this size is convenient for this plot. And SNS. So if you remember, we have imported matplotlib.pyplot as plt and cbon as SNS. So that's what we are using here. So SNS dot heatmap, and inside that mention the correlation, because we are going to plot this correlation value. So correlation, and so here we need to give some parameters. So after completing this parameter, I'll explain you what are these parameters. So color bar is equal to true, and square is equal to true, fmt is equal to dot 1f, dot 1f, and annotations is equal to true, annote kws. So let's give a size as size is equal to 8, and cmap is equal to, let's create blue color. Okay, so now I'll explain you what are these parameters. So let's run this. So we are plotting this correlation value. So you can see the plot here. So negative correlations have the negative value and the positive correlation have positive values. Okay, so the values lie, in this particular case, the values lie between minus 0.6 and plus 1. And plus 1 means they are positively correlated, and as the value proceeds towards the negative value, it means they are negatively correlated. So here the feature which is interesting for us is the gold. So we are going to predict the gold prices, so you can see which features are positively correlated. So you can see this silver column, right? So this gold and silver column has a value of 0.9. That means they are positively correlated. So that means if gold price increases, silver price also increases, and vice versa. If silver price increases, gold price also increases. So such kind of thing. So you can also see the other things as well. So you can see this SPX value and USO value, which has a minus 0.6 as their value. That means if USO value decreases, the SPX value will increase. So those kind of things. So this is about correlation matrix or correlation heat map. Okay, so we have this C bar is equal to true. So this is this color bar, and we just want this in square format. So we have given the square is equal to true. This FMT dot 1F means it's the number of decimal points we want. So we have just mentioned one floating point. So we have one floating point in the values here. So annotations is equal to true. So these are the annotations, the name of the column. So these are the annotations, and annotation size. This is the size of these annotations, and color map is equal to blue. So you can give any color you want to plot them in that specific color. Okay. So this is about correlation. So we find that silver is directly correlated with the gold price, and USO is slightly negatively correlated, and such kind of thing. Okay. So zero means they are not correlated, such kind of things. Okay. Now let's see the correlation values of GLD. Okay. Let's print correlation gold GLD. Okay. Now I'll run this. So you can see the correlation for GLD. So we have USO is negatively correlated and silver is positively correlated. So these are slightly negatively correlated. So this is the inference we are getting. Now let's see the distribution of this gold value. So it helps us to understand what is the range of the gold values. So I'm going to check the distribution of the gold price. So gold price. So for that, we need to use dist plot or distribution plot. So it is in Seaborn library. So SNS dot dist plot. So mention the data frame, which is gold data GLD. Okay. And let's now we need to mention the color we want. So let's put the color as green. Okay. Now let's run this. So as you can see here, we have, the most values lie in the range of, 120, and we have, less values around this 180 mark, and less values in this, 70 mark, and we have a bump in around 90 and in 160, but the majority of the values are in 120. Okay. So the price of the golds, you can see also the price in this first five columns. So you can see that during 2008 the price is kind of less, and during 2018 the price has definitely increased, and most of the price values lie in this 120 range, and we also have price in 180, but they are very less. Okay. So this is the density is nothing but the number of values we have. Okay. And we can clearly see that the more values are in this 120 range. Okay. So now we need to split this data to feed this to our machine learning algorithm. So here the columns that we are interested in is the gold column, right? So we will be feeding this SPX column, USO column, silver and euro and USD column, and with this columns we will try to predict the gold prices. So we need to remove this date column from our data set, and we need to separate this gold column as well. Okay. So let's see how we can do that. So now what we are going to do is splitting the features and target. Here the target is nothing but the gold price, and the features are nothing but the other stock price, the SPX, USO, unit, the currency pair. Those kind of things are the features in this particular data set. So I'll create X, and let's store all the features in this. So here gold data dot drop. So we are going to drop two columns here. So first is the date column. So I'll just drop date, and let's also drop gold column, and I'll mention this axis is equal to 1. So whenever you're dropping a column, you need to mention axis is equal to 1, and whenever you're dropping a row, you need to mention the axis is equal to 0. Okay. So I'll store this Y column in, sorry, the gold price column in Y. So gold data and GLD. Okay. So we are removing this date column from our data frame, and we are also removing the gold column, and we are storing it in X, and we are just taking this gold price column and storing it in Y. Okay. So let's run this. Now you can print this X and Y. So I'll print this X and C. So as you can see here, we don't have this date column and gold column here. So we have this four important stock prices, and we will use these stock prices to predict the gold price values. So I'll print y here. So this y contains all the gold prices. Okay, so we have successfully splitted the features and the target. Now we need to separate it into testing data and training data. Okay, so as I have told you earlier, we will train our machine learning algorithm with our training data, and we will evaluate our regressor using this test data. Splitting into training data and test data. Okay, so I create four variables: x train and x test. Okay, and y train and y test. Okay, so basically what I'm doing is I'm going to split the training data and test data. So this x will be separated into x train and x test. Okay, so 80% of the values will go into the x train, and 20% of the value will go to our x test value, and the corresponding gold prices will go to y train, and the corresponding gold prices for this x test will go to this y test. Okay, so we are just splitting this x and y into the x train and x test and y train and y test. So now we are going to use the train test split function. So you can see here we have imported this train test split function from sklearn.model selection. So let's use it now. Train test split, and inside that mention x and y, because we are going to split x and y, and the general test size we use is 10 percentage or 20 percentage. So I'll use 20 percentage. So text size is equal to 0.2. So 0.2 means 20 percentage. Okay, and random state is equal to random state, like you can give any values for random state. So the role of this is, if you want to split the data in the same way that I am splitting, you need to mention the same random state value. So if you use a random state is equal to 3, your value will be splitted in a different manner. So if you want to split the same way that I am doing, you just need to put the same value in the random state. So this is basically to reproduce the code exactly the same way. So we are splitting our data into x train and x test, and this y train contains the corresponding gold values for all the values in this x train, and the y test contains the corresponding gold price for all the values in x test. Okay, so totally we have about 2290 values, and in that 20 percentage is around 400. So okay, so our test size totally contains about 400 data points. So as I have told you earlier, you can use either 10 percentage or 20 percentage test data. So that proportion of test data is actually good. And now the next part is model training. Model training. So as I have told you, we are going to use a random forest regressor. So now I'll just give you a basic explanation on how a random forest regressor model works. Okay, so random forest is an ensemble model. So ensemble means it consists of more than one models joined together. So it is an ensemble model of a decision tree. So this is how a decision tree looks. Okay, so these are called as nodes. So these circles are called as nodes, and these are the branches. So let's say we have this this silver value, right? So this particular node will check the silver price value, and if the silver price value is in a specific range, let's say if the silver price is in the value of 0 to 5, it will go to this node. If the value is greater than 5, it will go to this node, and again it will check for some other values like euro and US dollars currency pair. So if this price range is in a certain value, it goes to one branch, and if it is the range is different, it goes to another branch. So this is how a decision tree works. And random forest is an ensemble models where we have multiple decision trees, and the value will be predicted using all the decision trees. Okay, so there will be n number of decision trees, and we will get different values from different decision trees, and this random forest regression model will find a voting system. So you can see the majority voting or average. So it will either find the mean value or median value of the all data sets of all the values predicted from these decision trees, and it will give us as the predicted value. So this is how a random forest regressor works. So it will just check for values in a specific range. Okay, so this is how a random forest regressor works. So now let's implement this model. So from sklearn.ensemble, we have imported this random forest regressor. Let's create a variable as regressor is equal to Random Forest Regressor, and I'll mention this n estimators is equal to 100. So this is the default number which we can give. And now let's train the model. So we have loaded this Random Forest Regressor to this regressor variable, and now we are going to train the model. Training the model. Okay. Mention the regressor. So regressor dot fit. So this fit function will fit our data to this regressor model, and by this our model machine learning model will be trained. So I'll put x train and y train. So the x train is the training data and the y train is also the training data. So x train represents all the features, and y train is the gold prices of those corresponding values in the x train. Okay, so let's run this. So we will get the various parameters that the model used as default. Okay, now we can. So now this random forest regression model is trained. Now we can use this trained model to make some predictions, and we can evaluate our model. So this part will be model evaluation. Okay, so we need to evaluate our model based on the test data. So we'll just make a comment here: prediction on test data. I'll create a variable as test data prediction is equal to mention the model. So here the model is nothing but a regressor dot predict. So we use this fit function to train our model. So we will use this predict function to predict the test data values. So this will predict the gold prices. Okay, so mention the x test. Okay, so x test is nothing but the training data. So as you can see here, so we have stored the test data in x test, so we need to mention it here. So let's run this, and this will give us the values for x test. So let's try to print this. Print test data prediction. Okay, so these are the values predicted by our model. Okay, so now we need to compare these predicted values with the actual values. Okay, so for that we can use some metrics. So here we are going to use r squared value, r squared error. Okay, so if you remember, we have imported metrics from sklearn library, and in that metrics we have this r2 score, which gives us the r squared error of our model. So I'll declare a variable as error score. Okay, so error score is equal to metrics. So you can see the libraries here. So we have imported metrics from sklearn. Metrics dot r2 score, and now we need to mention the real value and the predicted value. In this case, the real value is y test. So we are just checking for test data, right? So the real values are, or the actual values are y test, and the predicted values are stored in test data prediction. So we need to mention both of them in our r2 score. Y test and test data prediction. Okay, now let's print that r squared error. R squared error is error score. Okay, so we can see that the error score is 0.98. Okay, so there is not a specific value for error score that we can say this say that if the error score is in this range, that the model is performing well. So we cannot just give a general or a generalization for the r squared error value. So we need to see what is the range of the values we have in our data. So here the value is in hundreds, so hundreds or 150 or 120. In that case, error value of 0.98 is kind of very less. So that means our model is performing really well. But if we have values in the range of 1, 2, and 3, in that cases a 0.98 error score is kind of very less. Okay, in that means we have a huge error. Okay, so we cannot have a 0.98 error in those cases where the data is very less. And if the value is in the range of hundreds and thousand, in that cases the error score value of 0.98 is really good. Okay, so you can also use some other deep learning models like neural networks or recurrent neural networks, in that cases the error score will be much lesser. So that means the prediction will be more accurate to the original price. So there is also another way to analyze how well our model is performing. So what we will do is we will compare these y test, the actual value and the predicted value, by plotting it some in some graphs. Okay, so now let's do that. So we are going to compare the actual values and predicted values. Okay, so in a plot, so we are going to plot this actual value and predicted value and see how these values are, how close these values are. So before that, I want to convert this y test into a list, because otherwise it will give some error when we are plotting. So you can convert it to a list by y test is equal to using the keyword list. So this will convert this y test. So this is a pandas series data frame. Now we are going to convert this to a list. So y test, so let's run this. So this will convert it to a list, and now let's plot it. Plt.plot and y test, which is the actual value, and I want this y test to be printed in blue color. So blue, and let's put the label as actual value. Okay, so actual value are this, these are the real values. Let's also plot for plt.plot. Now we are going to plot the predicted values, which are test data prediction. Okay, so plt.plot test data prediction, and I'll plot this in a different color. So let's plot this in green color. So the real values will be plotted in blue color and the predicted values will be printed in green color. And let's give a label as predicted value. Okay, and I'll just give a title for this plot. So plt.title, it's actual price. So it's just a title for our graph. So actual price versus predicted price, and let's give the name for our x-axis and y-axis. So plt.x label, so this will give the name for our x-axis. So let it be number of values. Okay, and y label is nothing but the gold price, and plt.legend, plt.show. Okay, so this will give us the plot. Okay, so you can see this a tiny box here, which is actual price and predicted price. So actual price is in blue color and the predicted price in green color. So this is nothing but the legend of our plot. So when you mention this plt.legend, it will print this. Okay, so now you can see the price of actual price and predicted price, and the values are very close to each other. So the actual price is kind of slightly more than the predicted value. So this is nothing but this 0.98 error due to this. Okay, so if I just comment this line, so if you just put hash here, so it won't run this particular line. So first of all, let's try to run and see this. So we have this blue line. So blue line is nothing but the actual value. Okay, so on top of this, we are just plotting the predicted values, and we see that these values are very close to each other. So the predicted values are predicted on top of this actual value, and you can see the edges here. So these are nothing but the blues ones are nothing but the actual value, and the green ones are nothing but the predicted value. So as you can see here, the values are really close. So that means we have successfully used this random forest regressor model to find the gold prices based on several other stock prices. Okay, so this is how you can predict these values. So I'll just give you a quick recap of what we have done here. So in the first step, we have imported all the dependencies we want. So we have imported the pandas library, matplotlib, which is matplotlib is used for plotting, and we have imported the train test split function, random forest regressor model, and metrics for evaluating our model. So the next step is data collection, where we have loaded our CSV file to a pandas data frame. So and we have printed the first 5 rows of our data frame and the last 5 rows of our data frame. So and we have also checked the number of data points lines we have and the number of columns we have. And this data frame, so frame.info gives us the object type and is there any missing values in that data. So that is given by this info function, and we have checked the number of missing values using this is null function. So we don't have any missing values in this particular data frame, and we have also printed some statistical values using this describe function. Then we have find the correlation between different columns in the data frame, and we found that few columns are positively correlated and few columns are negatively correlated, and we have seen the distribution of the data points here. So we found that majority of the values lie in this 120 range, and we have splitted the feature columns and we have dropped the date here and gold, and we have stored this gold price value in y, and we have splitted the data set into training data and test data later using this train test split function, and we have trained this random forest regressor model using this fit function, and we have predicted our x test values, and we have found that we got some good error score value. And then we have plotted this actual price and the price predicted by our model, and we find that these values are almost close to each other. So this is how you can use a machine learning algorithm to predict some prices using some features. So I hope you have understood all the things covered here. So do practice this codes and try to understand it better. Okay, so thanks for watching.